Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 1st, 2025, just yesterday. The hook is simple. This paper launches a unified, open environment called GEM that lets large language model agents learn through interaction and shows that reinforce with return batch normalization often matches or beats proximal policy optimization and generative reinforcement policy optimization in multi-turn tasks. The paper is titled GEM, a gym for Agentic LLMs, and the implications for model training are quite significant. Beyond the core framework, the work standardizes response as action, benchmarks major algorithms, integrates useful tools like Python and search, and doubles as an evaluation suite for complex, long-horizon tasks. Also, the author shared a GitHub repo. It includes the GEM library with a GEM-like API, multiple ready-made environments, tool integrations, Python, search, MCP, and flexible wrappers. You'll find pip install instructions, quick start usage, runnable examples for math, code, QA, plus training integrations with OT and Veral, and tests to validate setups. Alright, the last segment framed the toolkit and baselines. Figure 1 shows learning curves across 5 categories, comparing reinforce with return batch normalization to the version without it. Return batch normalization means normalizing the batch of returns so the gradient update stays stable and credit assignment becomes clearer. The solid curves with normalization climb faster and peak higher in many panels, including Sudoku and Tower of Hanoi. This pattern signals that reinforce plus normalization delivers reliable multi-turn gains across diverse tasks. So while Figure 1 showed the training gains, Figure 2 shows how auto-reset in vectorized environments works. Vectorized environments mean many copies of the task run in parallel, which raises throughput. Auto-reset automatically restarts any copy as soon as an episode ends, so users just keep calling the step method without tracking terminations. This simplifies data collection and keeps critic learning correct, because returns do not leak across episode boundaries. So, Figure 3 contrasts 3 reinforcement learning formulations and what counts toward the loss, which the green tokens mark. The top left panel shows single token as action, which yields very long episodes and needs dense rewards. The middle row depicts response as action, which simplifies single-turn tasks but struggles for multi-turn credit. The top right panel treats the whole interaction as one action, which suits trajectory rewards but requires masking tool outputs. So while Figure 3 contrasted loss formulations, Figure 4 presents head-to-head learning curves across 8 environments. The takeaway is simple. Generative reinforcement policy optimization shines on single-turn tasks, but it falters in multi-turn games where stepwise credit matters. Proximal policy optimization often leads on long-horizon Sudoku, because a good critic helps. Reinforce with return batch normalization stays competitive and steady across settings, which signals a strong, low-overhead baseline. So Table 2 shows that question answering improves when agents train with reinforcement learning and use the search tool. Single hop means one direct lookup, while multi-hop requires combining facts across sources. The mixed environment model, with tool access, reaches about 46% on average, which is the best. The rightmost column shows the tool-enabled mixed setup leading the pack. The bottom average row highlights the overall gain across datasets. Alright, 2 takeaways stand out. GEM standardizes multi-turn training for large language model agents with a clean GEM-like interface and tools, and reinforce with return batch normalization proves a strong, low-overhead baseline that rivals proximal policy optimization and generative reinforcement policy optimization. The broader implication is faster, more reproducible progress on interactive, tool-using agents. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.